Okay, we have 1,000 Newton crate being pushed across a level floor with a constant speed. So just right there, the first sentence here, a couple things. So look, the 1,000 Newton crate. Is that the mass of the? Is this the mass of the crate? No. What is that? That's the weight. We're gonna need the mass for part B. So how do you get mass from the weight? Well, weight equals what? mg, right? So the mass will be weight over gravity. So that's going to be 1,000 newtons. Remember, a newton is a kilogram meter per second squared. And then gravity is 9.8. So the mass of the crate comes out as 102, about 102 kilograms. The meter per second squared cancels, so that's the mass. So we'll just make note of that. The mass of the crate is 102. And then also, the other thing I want to point out, the words constant speed. What are they telling you there? There's something really hugely important when you see the words constant speed or constant velocity. What are they telling you? A is 0, right? Another name for constant speed is zero acceleration. If something moves with no change in velocity, not going faster, not going slower, then the acceleration is 0. Okay? All right, so part A. My computer's really slow. Okay, so part A, they're telling us that a force of 300 newtons, so this guy right here is 300 newtons, is being exerted at an angle of 20 degrees below the horizontal. So below the horizontal is like, so if you draw in the horizontal right here, dot, 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 this angle in here is 20 degrees. The way I like to set up free body diagrams, I think it's the best way, have the forces coming from the center of the object. So let's clean this guy up. And we don't have part B yet. So let's take part B away and focus just on part A. So I'm going to kind of redraw this. So here's our object and the forces. So what are the forces on the crate? So we have the 300 Newton force exerted at 20 degrees below the horizontal. So show the angle, draw in the horizontal, dot, 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 dot. Okay, what other forces? We got mg down, and mg is equal to 1,000. Is the crate on a surface? Yep. So there's a normal force. Fn is normal force. And then there's friction. U times normal force. Hey, is this kinetic friction or is it static friction? It's kinetic. You know, is there really a difference in how you deal with static friction and kinetic friction? No. You know, the way you deal with it's the same. Kinetic just means moving. Static means at rest. You should know that static friction is always larger than kinetic friction. The force required to set an object in motion is always greater than the force required to keep it in motion. So that's it. Here's our free body diagram. And then which vector do we have to break apart? We got to break apart the 300 Newton force into x component, y component. So I'm showing that with red. So there's the free body diagram. So after the free body diagram, we sum the forces. Summing forces x, summing forces y. Okay, the x forces. What are the x forces on the crate? We have the x component of the 300 Newton, and we have friction. Those are the two x forces. So this is going to be cosine 20 times 300, right? That's what? That's this guy. Cosine 20, 300. And he's positive. Why am I leaving him positive? To the right is plus, to the left is minus, up plus, down minus. There's the sign convention. Okay, and then friction, minus mu Fn. Okay, any other x forces? No. So what is the sum of the forces always equal to? Ma. So we just wrote an equation. Now what's this A right here? It's 0 because they told us the crate's moving at a constant speed. So we can replace the A with 0. So Ma goes to 0. All right, in the y direction, how many forces do we have in the y? 3. We have normal force, mg, and the y component of the 300. Okay, so let's do those three. So we have normal force up, minus 1,000 down, that's the weight, then minus the y component of the 300, which is going to be sine 20, 300. So those are the three vertical forces. Okay, sum of the forces always equals ma, where that's a y acceleration. Is the crate going to accelerate vertically? Will it accelerate into the sky? No. Will it accelerate into the ground? No. So the y acceleration, we can just change it to 0. Okay? In my opinion, that's the hard part of the problem. You know, getting the free body diagram correct, summing the forces correctly. Once you're here, it's pretty much like 8th grade algebra, right? That's not hard algebra. So what do they want us to figure out? For part A, they want us to find the coefficient of kinetic friction. So we're solving for this. We're solving for mu. So take the x equation. Mu equals cosine 20, 300 newtons, divided by the normal force. Well, what's the normal force equal to? Let's figure out the normal force. The normal force is going to be equal to 1,000 newtons plus sine 20, 300. So when you punch that in, the normal force comes out as 1,102.606. So you can solve for the normal force. All right, then take that, plug it in over here. Plug it in over here. Mu comes out as 0.256. That's the answer to part A. Okay, any questions on part A? If you didn't get this correct, the most likely reason is you forgot the y component of the 300. You know? Okay, let's go to part B. Can I go back to the original? Okay, so now we're going to focus on part B. So let's get rid of part A. Okay, so we'll do free body diagram. Move this up here. So I'm going to erase this force again. So in part B, how is the force being applied? Is it being applied downward? So part B says if the 300 Newton force is instead pulling the block at an angle of 20 degrees above the horizontal, what does above the horizontal mean? The vector points which way? So here's the horizontal. What does above the horizontal mean? The vector points which way? Above the horizontal. What does below the horizontal mean? Below the horizontal means the vector points that way. Okay? So the 300 Newton force is being applied this way. And that's 20 degrees. We have mg down, which is equal to 1,000. We have normal force up, and we have friction back. Okay, so we got to break one of these vectors apart. We have to break apart the 300 again. X component, Y component. So let's sum the forces. It's going to be very similar but a little different. So summing forces X, we have two X forces again. So basically the X direction didn't change. The X direction is the same exact thing. Cosine 20 times 300 minus mu Fn equals ma. Now, does the A go to 0? Not anymore. The box will accelerate now. Hey, who can tell me why will the box accelerate now? What changed? Ultimately, what changed in the problem? What changed that's going to cause the box to accelerate? Two words. Normal force. The normal force changed. Why did the normal force change? Well, because look, is the force here, is this 300 Newton force, is it pushing the crate into the table or into the ground? The 300 Newton force is now pulling the crate kind of off the ground, which is going to change the normal force, right? Like if I take this book right here, if I push into the book like that, is that going to make the normal force bigger or smaller? Bigger, because the table has to push back. Now what if I go like this and I kind of pull up on the book? What does that do to the normal force? Makes it smaller. The normal force changed because the force is now, this 300 Newton force is now pulling the book above the horizontal. Okay, so the normal force is different. So summing the forces in the Y, we have normal force plus sine 20, so it's different than last time, than part A, 300 minus 1,000. That's the sum of the forces in the Y, equals ma. Will there be a vertical acceleration here? Nope. So the A goes to 0. Take this, solve for the normal force. The normal force is now 897.394. What was it in part A? In part A, the normal force was like 1100. So notice the normal force got smaller. Okay? Okay, so what are we solving for? Acceleration. So take this x equation. A is going to be cosine 20, 300, divided by the normal force. So plug in the normal force, you get an acceleration of about 0.51. All right. So really, it comes down to free body diagram, sum the forces. From A to B, what changed? From part A to part B, the only thing that changed was what? This 20 degrees went from below the horizontal to above the horizontal. And that changed the normal force.
Where did the mu go for the Fn difference?
Oh, good question. Spaldo, I forgot something here. This should be, sorry guys, oops, cosine 20 minus mu Fn. So you got to plug in Fn two places. Did I do that correctly? Yeah, I did it. Yeah. I wrote this out ahead of time and I had it right. So good question. So yeah, that goes there.
What about mass?
Where's mass? Oh, dude, you know what? Hey, Spaldo. That's M. That's not normal force. Darn it, the video is almost perfect. This is the right answer. I just did bad algebra. So yeah, the denominator is M. Okay.